It's been said that about half of the people on the planet are terrified of change, and that almost the entire other half can manage change, they're okay with it, perhaps some of them can be project managers of change, but there's just a very small minority who are crazy enough to know that if they deliberately make change occur, that destabilizes everybody else and gives them a competitive advantage. A portion of those people go into fintech, but let's make no mistake that within the banks, and there are a number of big banks here present, that there are agents of change who are fighting back. And the greatest opportunity for them to do that today is artificial intelligence. Now, why is that coming about? It's coming about because of what we call digitalisation. The world has changed. In the days when Ted here was a young man and would wander into a bank and ask, please can he have a bank account, perhaps the bank manager might have asked who his parents were. In my case, they asked my father to sign for it. 3 years later, they asked if I would like a credit card. Can you imagine that today? Today, someone goes into one bank and they say, I want a checking account from you. And they say, would you like a credit card? No. I want this credit card from this bank because that's going to get me into the lounge. And I want my loan from these guys over here because they've got the cheapest rate. And so as individuals, we now build our community experience based on what we want. So for banks to maximize our loyalty and our share of wallet, that's very simple. All they need to do is build a computer system that is entirely unique for me. And another one for you, and another one for you. It's pretty expensive, right? It's not going to work. So the process is to build a computer system that can predict what it is that we want in advance, tell us what it is, present it to us before we go somewhere else. And that is what digitalisation is. In fact, if we can go to the next slide, this is becoming so important for banks that there is an arms race going on. JP Morgan alone, in the last 2 years, has spent $20 billion looking at their data, organising it, and building algorithms to move themselves towards digitalisation. Now, when I spoke to them about this, and I said, well, why would you spend that much money? Because it's the new Uber. To which my response is, Uber has never made any money. And at some point, a little kid's going to see them walking past and say, they've got no clothes on. Before we make these investments, we must understand what they are and what value they will bring. So move on to the next one. So how do we do that? Well, the first thing we need to understand is what is artificial intelligence? And it is, in fact, very simple and very easy. It is only one thing. Artificial intelligence is a prediction. And when we understand that it's a prediction, then we can understand how we fit that into our business model. We do it like this. We start by looking at our key processes. Perhaps for our banking world, we're a capital markets firm. Maybe that is foreign exchange, front to back. Within that process, we can then break it down into its workflows. And within those workflows, we can identify where a prediction might occur. And once we can see where the prediction is, we can then ask ourselves the question, if this prediction was done by a machine, which can do it with much more data, much more history, and far faster than a human, will I or will I not get a better prediction and a better outcome than the humans that are doing it today? So we identify those predictions, and then we need to do one other thing. Let's just move forward one more. We need to understand what we're training that prediction to do and what value it's going to have. And what do we mean by that? Well, just because there's a prediction doesn't mean that it's very simple. Prediction engines work on data. And the reason why banks have a distinct competitive advantage over the new upstarts within the fintech industry is that the banks own 30, 40, 50, 60 years of data that fintechs do not have access to. And I'm sure there are some legal questions we can talk about around who owns the data and the outcome. So if we have a problem, we then look at that problem and its prediction, and we ask ourselves, how are we going to train our prediction? And let me give you an example. Let's imagine that I was to build an artificial intelligence engine that read all of the CVs that I've received, looked at all the people I've employed in the past, and predicted for me who from those CVs I might employ in the future. Make sense? Sounds like a good use of artificial intelligence? Yeah? Except for some crazy reason, I've always employed people who are under 4'2". Do you know what the artificial intelligence engine is going to do? It's going to find all the people under 4'2" and tell me that they're the people I should employ. Why? Because I've trained it on my bias. What if I was to ask it to look at the people who have been in my company the longest and have been promoted the fastest, and to identify those characteristics in the CVs that I've received and match them? Will I get a better result? How we train our prediction is exceedingly important. But it is only a prediction. And this is where we need to understand the difference from a regulatory perspective. You cannot audit and you cannot do regulatory control on artificial intelligence. Why not? Because it's not a set of rules. You can't put a coin in at the top and determine where it comes out at the bottom. When you create an artificial intelligence prediction engine, at the point of birth, it is literally like a child. It knows nothing. And we train it with 50 years of data. But just like us, I can't audit your brain or yours. But what I can audit is what you did with the prediction that you had. And those outcomes are different. Let's just try it very, very quickly here. If I was to tell you that there is a 64% chance that it's going to rain tomorrow, how many of you would bring an umbrella? I would. Now it's interesting, there's only 7 or 8 of us here who would bring an umbrella. If the prediction's the same for all of us. And yet our judgment of that is different. How we take the prediction and we use that prediction in an automated way if we want to, or if we have a human involved, we can audit the judgment. Once we've made a judgment, we can then take an action that will give us a result. From that result, we learn something, and then we're able to train our prediction engine over time so that the percentage prediction gets higher and higher during the course of the usage. Let's move on pretty quickly. There are 2 stages that need to be done before we build anything related to artificial intelligence. The first, and it's essential, is not to spend $20 billion just because we think it's an arms race, but to use a mathematical means by which we can look at the potential value that a prediction will bring within a process inside our business. We do that as a company using our own model of a risk-adjusted economic value add. That respects the fact that artificial intelligence is not right or wrong. It is what? It's a prediction. It's a percentage probability that something will happen. So the investment must be based on that prediction being correct or incorrect. We then need to do a technical validation. Can we code it? Do we have enough data to train it? Is that data structured or unstructured? Can we get hold of it? Once we've done that, just move on, we can then build a prediction engine, preferably using DevOps. And do you know how long it takes to build a prediction engine? You're going to be shocked. The vast majority are completed within 2 weeks. Several of them are done within 3 or 4 days. It's actually not that complicated. But here is what is complicated. Once we've developed it, we can just move on, we then need to train it. And it is the training that makes the difference. So as we feed the data through our engine, we can see whether it's hitting a 60, 70, 80% accuracy. We can add more nodes if it's a neural network, or layers if it's an LSTM, more features. We can add weightings to our features and try and get that prediction as high as we possibly can. Once we've done that, and we have an engine that is performing reasonably well, we can put that into production alongside an existing process as a pilot. And once we can see the value, we then take the existing process away, we leave the automated prediction process in place, and that moves us closer and closer towards a predictive model, which is what digitalisation is all about. Now, we're doing some of this here in North America, we're doing some of this in Brazil. Why is this interesting here in this context? Because in order for us to train our models, we must have the data. And fintechs have been disrupting the world for a long time. However, fintechs do not have and cannot own the 50 or 60 years of data that banks own about our experience. Where that has been done before, Mark Zuckerberg has ended up in front of the government. And today, I believe, the head of Google is sitting up at Capitol Hill trying to explain what's been done with his data. So we can, as fintechs, put our artificial intelligence modules inside a bank. We can train them on bank data and we can produce an outcome. And our model learns from that outcome and becomes more valuable over time. Just as a final thought, given that that model has been perfected because of the data provided by banks, who now owns the perfected model?